In this video, we're covering the discriminant. So the discriminant helps us find the solutions, or sometimes the roots. The roots and the solutions are just other words for x-intercepts of a parabola. So the same way we use the quadratic formula and the axis of symmetry formula, we have ax squared plus bx plus c, all right? Except this time the discriminant is now the part of the quadratic formula in the square root sign, and it's given, this is it here. So delta equals b squared minus 4ac. So the discriminant tells us some really good and valuable information about the roots or the solutions of a quadratic equation that can help when we're trying to sketch or graph them. So if you end up finding that delta, so delta is just the triangle symbol there. If delta is greater than or equal to 0, you have two roots or two x-intercepts. And if it's a perfect square like 1, 4, 9, 16, 25, 36, 49, then the roots are what we call rational roots, and they're whole numbers. If delta is not a perfect square, so any other number there, then the roots are irrational and they're decimal places or surds. So if you end up with a delta that's greater than or equal to 0, you'll have something like what you see on your screen there, where you see the parabola going under the x-axis and it's got two x-intercepts. Now, when delta equals 0, there's two equal rational roots. So essentially what that's saying is it crosses or touches the x-axis at one point. It has one x-intercept, as you can see in the image at the top of your screen. Now the last one is when delta is less than 0, there's no roots, it doesn't cross the x-axis at all, it's well above it or well below it. So as you can see there. So the first example we're going to look at is we need to find the discriminant of this 2x squared minus 2x squared plus 3x plus 7 and state whether the roots are real or not real. In other words, there's no solutions. All right, so we start by y equals, well not y equals, sorry, 2x squared plus 3x plus 7 equals 0, where this is my a, b, c. The formula, remember, is delta equals b squared minus 4ac. So delta here is going to equal 3 squared minus 4 times 2, because all we're doing is substituting in, times 7, and that equals negative 47. And remember, if we have delta which is less than 0, it has no real roots. So therefore, we can say that 2x squared plus 3x plus 7 equals 0 has no real roots. Alright, our next example here is when we have an unknown in the middle. So find the values of r for which the quadratic equation x squared plus rx plus 1 equals 0 has equal roots. So we know the first thing I'm going to do is write it down. So x squared plus rx plus 1 equals 0. And we know that this is my a here, so a is going to be 1, b is going to be r, c is going to be 1. So we know that the important part mentioned up here is equal roots. And I know for a quadratic to have equal roots, my delta needs to equal 0. All right. Now I already know what delta is because we said delta equals b squared minus 4ac. So this is kind of like your simultaneous equations thing. So we're going to say that my b squared minus 4ac here, we're going to change my delta up here to that. So essentially what I'm saying is that we need b squared minus 4ac to equal 0. It has to equal 0 for this to be true. So now I can do my substitutions, where I've got r squared minus 4 times 1 equals 0. And then, so r squared minus 4 equals 0. We're going to plus the 4 to both sides. We end up with r squared equals 4. Then we'll square root both sides. Now that 4 cancels that. So I end up with r equals, now remember this, plus or minus 2. All right, plus or minus 2.